Today we are going to start with our new unit on logarithms and exponentials, and it's just kind of an introduction today. You've probably seen some of this stuff today, but it's a little bit of a refresher. Before we really go into logarithms, though, let's look at some exponential rules that you should know at this point, but if you don't, now would be a great time to know it, or to learn it. I'm going to put up 3 problems, and I would like you to simplify them. I will give you a few moments to simplify these 3 problems, and I will pause while you do so. To start us off, row 5, person 2. Big Quinn, hello. Would you like to give us your answer for one of these?
Sure. So 9 to the 1/2 power is 3.
And how did you arrive at 3?
That's the 1/2 power.
1/2 power is the same thing as the square root of 9, which is 3. Jump in steps. What if I had given you these things with 9s? Okay. What if I had given you 27 to the 1/3 power? It would be 3, because this, instead of a square root, the 3 tells us it's a cube root. So if you ever see a fraction, you know it's some kind of root, and whatever is in the bottom of your root right here gives us this number right here. And then inside is the 27, and the cube root of 27 is again 3. Awesome. Quinn, would you like to call on somebody? Fair enough. Row 6, person 5, comes back up to Walter. Okay, so if we wanted to just write that as a fraction, what would that be? 1/3. So if we're looking at 3 to the negative first, that's kind of the same thing as the inverse of 3, or the reciprocal of 3, which you just flip it, so it just becomes 1/3. Awesome. This final one. Walter, did you want to call on somebody? Row 4, person 2. Bobby, could you tell us what you got for this last one?
1/3.
And how did you get there?
Because 9 to the 1/2 power is 3.
Okay, I'm going to pause for 1 second. Resuming right now. So you said 9 to the 1/2 you did first.
Yep.
So then you got 3, and then what's left for powers?
And negative.
And so we have 3 to the negative 1 that's left, which is just the same thing as 1/3. Awesome. So looking at these, just knowing what to do when you have a fraction in your power, or knowing what to do when you have a negative in your power, or if they're combined. These are tips and tricks that you will definitely need to know for this unit. Okay, moving on. Today, if I were to give you, I want to know if I have 4 to some power, what power will get me to 64? Write it down on your iPad. When you think you have it, flip your iPad around and show me. If you're not sure, ask the people around you. Maybe they have an idea. Yes, yes, yes. Close. Yes. Yes, yes. Yes, yes. Yes, yes. Yes, yes, yes. Yes. Can you make it bigger? Yes. Awesome. So basically, what this question is asking us is 4 times some number of 4s multiplied together will get us to 64. And I know that 4 times 4 is 16. Times 4 is 64. So x would just equal 3. 4 to the 3rd power will get us 64. But what if I asked you, I want to know 5 to what power will get me 8? All of a sudden, I don't know about you, but I don't think 5 goes into 8 nicely at all. So this is the point where we need to rewrite this. Does anybody remember what this form is called? It is our exponential form. And if this is our exponential form, let's look at the parts first. What is this called? That is indeed an exponent. Thus, exponential form. Does anybody remember what this part is called? What do you think? That is indeed our base. And this last part right here is our argument. So we have a base, we have an exponent, and we have an argument. And if we were to take these and put them into logarithmic form, we would end up with, you start with your log, and we need something here. Would our base go there for our argument or our exponent? Take a few seconds, turn and talk. Base, argument, or exponent. I expect everybody to at least have some answer.
Everybody knows that.
And the answer. Alright. Andrew, what do you think it is? It is indeed the base. Right here, your base goes here. Okay. Not the argument. Because if we look over here, we have our base, then our argument will go here. So remember, we have log, and then we have like a small number, and that's our base. And then we'll have our argument, which is the main number. And then this is equal to our exponent. If I wrote out each of the things that they were, so this is a base, so it's a b, and this is an argument, and that's my exponent. I won't say it.
Don't, just don't.
I'm not going to say it, but if that's a way that you can remember. Okay, it has been said. So, if you can remember this term base, I believe this is like the first generation that we can use where this actually makes sense to people. I think before this it would just be like, what? I don't get it. But, always remember, Franny said it, so I can say it now. Log is bay. Okay. So, if that's the way that you can remember it, you're going to be like, oh, that's so lame. But now you're going to remember it. I guarantee you, you're going to remember it. Okay. So, now that we've figured it out, now I want to solve for x. If I solve for x, can I just plug this into my calculator? I could. So let's do it. Oh, I have to put this away. If you don't have a calculator, follow along up here. Actually, I believe I have extra calculators. So if you need an extra calculator, let me pause while I give out extra calculators. Now that we've handed out calculators, if we were to put this into our calculator now, there is a log button, right? The log button's right there. Except I need a base of 5. How am I supposed to get a base of 5? If you have a newer calculator, there is a way that you can do that. If you have an older calculator, there is no way for you to change the base using the calculator. But you can use a little bit of math to help you with the calculator. So if you do not know how to change the base, or if you have an old calculator that refuses to let you change the base, here's a way that you could. If we want a base of 5, what we could do, excuse me just a sec. If we have a base of 5 and we have an argument of 8, we can write this as log of 8. And on our calculators, when it says log and it doesn't give us a base, what is actually the base? So this is like an implicit 10 on our calculator, and they just assume that if it just says log, and then it says nothing else, then it is log base 10. So we'll have log base 10 of 8, And if we want to change this to base 5, all you have to do is just divide this by the log of 5. And if you do this, this right here is equivalent to if you wanted to solve this with a base of 5. So for people who cannot or do not know how to change their base on their calculator, you can also just put in log of 8 divided by the log of 5, and you'll get out our x value. So someone who has already calculated out this x value, what did you get? 1.29 and then some other stuff, right? But let's see if it actually works. Let's put it back into our original equation. If we put it back into our original equation, do you end up with 8? Do you end up with exactly 8? You use the answer button. Last period, I got questions asking, where's the answer button? I don't know where it is. If you do not know where the answer button is, the answer button is a pretty great invention here. If, for instance, I had the number 5, and I wanted to get the number 5 without having to type in 5 again, I could go to second, and then the negative sign here, above it, there's a little A and S. That's our answer button. And if I pushed that and I pressed enter, I would end up with 5. Did you also know that your calculator can store, like, I think up to about 30 different numbers at one time? There's a store function. And if you see this STO on your calculator with a little arrow next to it, if I wanted to store 5 and use it for later, I would type in 5. I would press that STO button, and it gives me a little arrow. And then, do you see all the green letters that are on your calculator? Those are actually just variables that you can use later. So if you press alpha, the green button, and then I just hit math, above math there's an A, and all of a sudden, it says, okay, I've stored 5 in A. So in about 20 years, when I want to use 5 as A, I can just hit alpha, A, enter. Oh look, 5, I still have it. When you're doing problems where you need like 20 different numbers and you don't want to round any of those numbers until the very end, this is your life. That's a fun little thing. Okay, moving on. From here, if you press the answer key and you put in that entire decimal here, you'll get something that's either 8 or it's like 7.999999997 or so. And that's a lot closer than if you just put in 1.29. For someone who just put in 1.29 as the x value here, what did you end up getting instead of 8? Was it like 7.97-ish? Somewhere around there. You've probably gotten something around 7.97, but 7.99999 is a lot better than that. Okay, I would like you to try, on your own, 2 more examples of this. One of the examples, 3 to what power will get you 10? And 16 to what power will give you 1/4? So take a few moments. Question? Yes. On some of the calculators, there is indeed a way to change the base. Would you like to see it? Okay. If you have a newer calculator, I don't know how new it has to be. If you have one of these TI-83 pluses, I don't think it works on this. I think it works on the TI-84s, maybe, possibly. So you can try it and see if you know how to do this, or if you can do this on your calculator. To change the base, you would hit math, and then you can keep on scrolling, like all the way down to the very bottom. Or if you press alpha and then A, it pops up with this log, and then it has boxes for you to fill in with like a little base blank and with the number base, a blank, an argument blank. So if you would like to try on your calculator, see if it works on your calculator. If it doesn't work on your calculator, you're just going to have to remember how we change the base using our log properties. Show of hands, who was able to get this on their calculator to work? Okay. Do some people have old calculators and it wasn't able to work? A few people. Okay. But yep, that's how you'd use it. Okay. Using that, see if you can solve these two, and I will give you some time to do so. A little bit of, ooh, there we go. Now that we've had a little bit of time, row 4, person 6 comes back up. So Ryan, could you tell us what you got for one of these two?
Oh, I got 2.095.
So 2.095. So 2.9-ish or 2.10 or 2.1, rather. 2.09, 2.1, somewhere around there for x. All right, would you like to call on somebody? Dice of Destiny. Row 4, person 5. Katie? Negative 0.5, which is the same thing as negative 1/2. Okay. What time does this period end? 39-ish. Okay. So 39-ish. Let's do one problem, the opposite direction, and then I will give you work time. So, if I want a problem in the opposite direction, what if I wanted to solve for this x? Think about how you would have to order it. Right now it's in logarithmic form. We want to get it into exponential form so we can solve for x. I'll give you a little bit of work time. Try and solve for x. If we want to first rearrange this into exponential form, row 2, person 2. So we have our base, and here is this is our exponent. So since we have our base and our exponent, they have to go there. And then our argument right here is x. And what is 4 to the 4th? 256 is equal to x. All right. For the rest of the period, test corrections if you want to do them. Can lab help if you need it. Or otherwise, here is the homework for today. Somewhere. If we look at this first page for the homework, I would like you to do the first 4 on the left-hand side. And if you look at the second page, I would like you to do the first 5 on the left-hand side. That is all for homework for today. So the rest of the time is yours to work. I will end our recording here.